Hello, I'm Brenda Mertens from Montpellier, south of France. Did you realize that telescopes are nowadays really in? Well, the NASA just launched one of the biggest telescopes into the space so that we can watch and see the first stars and the first galaxies. Also, the Netflix production just had his new film with the title Don't Look Up, which is also about a huge telescope where we can look at one of the comets that come to the Earth. And what's going to happen? We need to watch. Well, now I want to talk to you, of course, about telescope, but more in dentistry, of course. And for that, I want to talk to you about one of the articles that was just published in the International Journal of Prosthodontics. The title is Rationale for Novel Attachment System for Implant-Supported Overdentures. Well, this article was written by the group of the Department of Prosthodontics in Hamburg in Germany by Professor Karl in Holly's crew. The purpose of this article was to quantify the effect of support stiffness on the retention forces of telescopic crowns and to evaluate a prototype attachment system incorporating a nickel titanium element, so something really new. In the first part of the study, telescopic crowns were fabricated employing standard laboratory procedures. For 6 combinations of telescopic crowns, the separation force was determined while varying the stiffness of the supporting implants. In the second part of the study, an in vitro mandibular model with 3 interforaminal implants, one in the middle, one on the left, one on the right canine, was equipped with strain gauge and extensometers. 2 procedures, either employing cylindric telescopic crowns or prototype attachments, were fabricated and statically loaded on the model using either the midline or the left or the both canine implants for support, while strain in the peri-implant area and prosthesis displacement were recorded. Well, the results are really interesting. For the first part, with one exception, for each assembly of 2 telescopic crowns, the separating force was always dependent on the stiffness of the supporting implants. With 3 exceptions out of a total of 14 comparisons for peri-implant strain and prosthesis displacement, the use of the prototype attachments always led to significantly lower mean values compared to the use of cylindrical telescopes. So what can we conclude? Well, actually, the individual force, retention force, of telescopic crowns on implants should be at a lower level compared to telescopic crowns on natural abutments. So incorporating a nickel titanium element into attachment systems for implant-supported removable prostheses reduce the peri-implant strain and may facilitate the use of telescopic crowns. Well, this novel concept needs, of course, to be utilized, to be more studied, and maybe we can recommend it in the future. For now, I want to thank you and stay tuned and watch more videos about bringing to life the International Journal of Prosthodontics.